welcome to today's Gyan Darshan presentations. Today will be topics related to tutorial on multimedia. Let's start about today again I will be talking about the basics of multimedia. I will give you some definitions of multimedia, give you various examples of the multimedia, identify the number of topics of multimedia. Again, we try to discuss little bit of where multimedia can be used, and then we'll talk about some details about some of the components of multimedia. So basically, my discussions will comprise of the following topics. We'll talk about the definitions first, but before definition, I will be talking about giving you various examples of multimedia. Then we have lots of buzzwords in the multimedia. One is called hypertext, hypermedia. We'll talk about what is the hypertext, what is hypermedia. We'll talk about some of the components of the multimedia, but again it will be not possible for me to go more than one component today, and I will be talking about only one component, that is called image component, and also we'll talk about another component which is a part of the multimedia, and that is called the color component. So basically, definitions, examples, some buzzwords, and some of the important component of a multimedia. See, basically the one point must be clear to you, that this course does not mean that it contains only practical components. You have to understand the lots of theoretical issues, and that is our focus in today's presentation and the subsequent presentations as well. So let's talk about is basically, people say that you talk to many people and they all will come with many definitions of the multimedia. As many people, so many definitions you will find out. But before coming to some definitions, let me give you some example of what is real multimedia is. Let's see now, for example, it is a catalog of fancy and luxury model of cars with a guide to help you buy one. You can see now, this is can be, you can see certain package which will show you various models of the fancy and the luxurious car, and there will be a guide to help you which one you have to pick up. That is also one example of multimedia. It could be, let's see now, it could be real-time video conference with software professionals sitting on their office computer in different countries and discussing certain projects. So that is another example of a multimedia. That is, today the video conferencing has become an important tool, because time is very costly affair today. So people don't travel and discuss all the costly and the projects and through multimedia. So we have lots of tools are available, cooperative tools, collaborative tools are available on the market, through which they collaborate and work on certain projects sitting in different countries and working with on their computers. So this is also one example of what we'll call them multimedia. So real video conferencing now, and it is going to be reality now, that sooner or later you will see that video conferencing has become the important component of the whole exercise. Again, it could be a science lessons. Now today lots of CD-ROMs are available containing science lesson on physics, chemistry, mathematics, and other games for the school children. This is also one example of a multimedia. Or it could be just now it is Google Kids flying fighter planes in Sweetie virtual reality. This is also one of example of a multimedia. So I have given you number of examples of a multimedia, and you can think of many other examples now of multimedia. Now what it leads to now, with all these basic examples, you can come to some definition what multimedia is. Look at these definitions now. It is a combination of text, graphics, art, sound, animations, video delivered by computer or other electronic means. So basically what we are talking about is that any multimedia software will comprise of many components. It could have a graphics art, it could have animations, it could have a colored, it could have a sound, it could have a video clipping. So you can comprise of many components. So this is whole thing. If you combine them together, then only you can call them that this is a multimedia. Multimedia is a really challenging task to do it. It's not only science, but also it is basically art. Now what exactly is that? It is a richly presented sensations. Now if you basically, multimedia excites, let's go further, multimedia excites eyes, ears, fingertips, and most importantly heads. If you are able to combine all these elements together, it could have a very important influence on the people's mind. For example, basically what we are talking about is that you have a very interesting pictures, you have a very attracting video clippings, you have very melodious music, and if you all combine together, you can have a very good software which will have effect on the people in certain areas, so that they can get motivated to do something. Sometimes if you, by reading simple text in a linear fashion, you are not able to do anything, but if you present certain things, like example of today, the school kids now, the syllabus is heavily loaded, and sometimes the teacher is not able to explain certain concepts. Basically, take example of the science, which is a little bit abstract type, and if you can explain all these concepts with a multimedia thing, then it can teacher and the students can understand this concept very much easily now. So basically, we can talk about different type of multimedia. It could be interactive multimedia, or it could be non-interactive multimedia. What exactly we mean by the interactive multimedia? You have worked with, if you take any software through which you can play around. For example, if you download any Java applet, you have a certain applet, what we call them the very tic-tac-toe applet or many other type of applets. If you download these applets, you can interact with those applets, you can input certain data, you can again get something else, and so on. So if you are directly talking to the software, giving some input, getting some output from the software, what we are talking about, the interactive type of multimedia. Now here is the designing a interactive type of multimedia definitely is much more challenging than designing a non-interactive multimedia. For example, what is the example of a non-interactive multimedia? For example, you see certain serials or certain programs, you watch certain programs on your television. This is again example of a non-interactive multimedia. You don't do anything, you just basically you watch and you can't do anything. Again, you can watch any movie on your television, again it becomes very non-interactive. So we can talk, what we are talking about is that there are two types of multimedia. One could be very interactive multimedia, and then another could be non-interactive media. So depending upon your needs and requirement, you can go to any type of streams and you can design this one. Now there are lots of tools are available in this one. In fact, I will be talking about there is something called, what we are talking about is the authoring tools now. Just look at this slide now, that what is the authoring tool, and there will be a separate presentations on this topic now. Now, what is the authoring tool is? The software, it is software tools designed to manage individual multimedia elements and provide user interactions. What it does, it provides facilities for creating and editing text and image. So various ways I can design a multimedia software. One way that I must have a authoring tool. So the advantage of a authoring tool, which is what we call the multimedia software, is to create different type of components: audio components, video components, animations, graphics, colors, and then the real advantage of this software is to combine all these components together and produce a product. So this is what we call them the authoring tool. So authoring tool is a software which helps you to create a different type of components which we listed earlier, which is part of the multimedia, and also combine them together to become a interactive or non-interactive type of a package. It also provides you facilities and creating and editing all types of elements which you have thought of. So basically not only simply create and combine, but later on if you want to do certain modifications with this existing software, that also is possible for you to do it. Now again, what are other features of the authoring tools? The one is that it provides the extension to video disc players. You can store that software into your video disc. You can also store your software which you have created into video tape players now. So this is another advantage, another feature of a tool, what we'll call them authoring tool now. And again, I told you that you have to do some practical session. In fact, we have listed on the internet around 5 or 6 sessions on the authoring tools, and depending upon the availability of the software at particular TLC, we have not emphasized Macromedia Director or any other software tools of similar kind. You must have 5 or 6 practical sessions on this topic. Now there is another important concept, another important, we are talking about, we'll define number of buzzwords in this one. What I told you listed earlier, that the hypermedia, the hypertext, all are buzzwords in the multimedia context. The another important concept is called what we call the multimedia highway. This important concept which always you come across in the newspaper. Now, what is the multimedia highway? Let me define this term. Now, first thing, let me see what are the important components here. Formations of there is train today, there is now the government is basically the government and many other agency. So basically formation of national information infrastructure, this is basically by multimedia. We mean what it comprises is, it comprises government organizations, cable operators, telephone companies, computer companies and the internet to provide feature movies and real-time news at home or TV computer at any time from anywhere in the world. Now here is we are talking about some new trend taking place today. Today we are talking about the era of convergence. Earlier we are talking about combinations or the convergence of only telecommunications and the computer. Today we are talking about convergence of many other technology. We have the telecommunications, the cable, the media, and what we have, the internet is coming, the computer is coming. All are coming together and getting all the features at your TV. For example, soon after some time you will see that you can have at your television you can have live features, live news from a different parts of the country at your television. You can download any movies from anywhere around the world and watch at your televisions. So it will be possible only when we have all these 4-5 technology combined together, so that there will be no problem of the convergence, no problem of compatibility and so on. So basically what we are doing at the computer, same thing can be displayed on your computers and on your television and so on. So basically for that you require a very high bandwidth. Today we are talking about that the infrastructure has to be created so that so that you can have all the multimedia features not only at your computer but also you can have at your televisions also. So all things by multimedia, let me summarize very quickly what we are talking about is, by multimedia highway means the convergence of various technology with very high bandwidth, so that all the things which are available otherwise can be available at your computer or at your television, so that you can have anything at any time from anywhere around the world. This is another important milestone in the multimedia technology. Now again, it seems to be very simple. We have given you a small definition of a multimedia, that it is a combination of a few 4-5 components. But designing a multimedia is not so easy. Let's look at here what we are talking about is that although the definition is simple one, making it now can be complicated. What is the complexity involved with it? Not only do you need to understand how to make each multimedia component separately, but also you have to understand the multimedia computer tools and technologies to combine them together. So basically complexity involves is that you have to understand lots of other technology to produce the multimedia components. Right? For example, if I want to design an interactive multimedia, I have to do very non-linear programming. I have to do combining many components, do lots of synchronization, understand various technology, how to produce the CD-ROM and so on. So it is basically complexity involves in understanding the environment, and so that is why it's not so easy to design a multimedia, but it's not difficult as well. But one has to understand the complexity, that technology is one side, the tools and environment is another side. So you have to combine them together and produce a good product. Now here is basically the another thing which you have to understand is that today so far the CD-ROM has become the intermediate memory technology for the multimedia now, till we find some new type of memory technology now. It is one of the cheapest and the most convenient technology for delivering of the multimedia. All the multimedia software today we have available in the CD-ROM. But before now, let's move to talk about, of course, these buzzwords are related to one component of multimedia, what we call them text now. Now what is hypertext now? Hypertext is a text-based which supports links to different text in the same document. I can have a linking with same document or even a different documents. These links allow the user to navigate through the document in non-linear or non-sequential formation. So basically, when we say the hypertext, means your text is linked with another text. That text might be linked with another. They might be part of the same document, or they might be part of the different document. They might be lying on the same machine, or they might be lying on the different machines. So basically, when we say the online learning or online courses, or basically take our BIT program, is basically meant for learning in online environment. By online environment means that learning through hypertext mode. You are reading one screen, you download a one import page from internet. Now you want to have additional information, then you click this one through click through your mouse, and then you can refer to another document. So basically, we are reading not in a linear fashion, we are reading into non-linear fashion. Suppose that you want to play around with certain multimedia component, you click this one, you will reach somewhere else, and so on. But when we read the text, we are basically reading in a sequential manner. But the purpose of the hypertext is to link a number of documents. They might be lying on the same machine, or they might be lying on the different machines. And the similar term is what we call them hypermedia. Now hypermedia is same just like a hypertext system, but that is not restricted to text documents, but includes other media, animations, graphics, video and audio. It could happen something like this, that when I am reading the hypertext, I can also link my text with another document, another component called multimedia. Then it becomes hypermedia. So not only I can link two textual informations together through hypermedia concept, but also I can link text with other multimedia component and so on. Then it becomes hypermedia, or it could be hypermedia in total. Like you click one image, then it might have more information about something into different document that will have another image and so on. So you can link two images, you can link two graphics and so on. That also is a combination. That is also one example of a hypermedia. But hypermedia also could be, the text could be linked with graphics could be linked with another text and so on. So they all are example of a hypermedia and hypertext. Now let me repeat now that we are talking about the components of multimedia, and there are large number of components of the multimedia. Image is one, video is another one, the sound is third one, the fourth is the text, and fifth is animations. So we'll talk about one of the few components here. Let's start with image, what exactly image is, and then we'll talk about color also, which we not listed, but we'll talk about the color component as well. Now what exactly we mean by the image now. Now first let me give some informations about what is image is. Let's say visual element. Image is a visual element or a graphics that make up a multimedia screen. So what you see on your multimedia is a basic image, right, which comprises of number of graphics components. Image can be, go further, the image can be scaled to different sizes. It could be colorized, right? I can scale them, I can make them bigger, I can make them smaller, I can change their color, I can modify its color, I can place any image in front of or behind any other object, or I can make the image invisible or make it visible on the command basis. This is what example of a what we'll call them the image now. So you see, when you switch on your computer is basically is a blank now. It does not show anything. Now whatever you see after that, after pressing a command, you see some graphic elements. That is your image. An image has many properties. As you can play around with image with any package. You can, if you have worked with computer aided design package, or you work with any Corel Draw or any graphics or any package, you will see that how image can be manipulated. Just like you manipulate your text, you can move it from here to there or cut this one. Same way you can play around with the image also. The image are, again, there are various formats. The basic purpose is that you have to learn many formats for all these components. What are the formats are there? We are talking about still images. still images are generated by the computer in two ways. There are two formats for presenting or representing or storing the image now. One is what we call them vector image, and second is called what we call them bitmaps now. So we'll talk about the advantage, disadvantage, compare these two formats, in what context you use one, what context you use the second one, and so on. So let's first talk about the vector image. Now what is a vector? Right? So vector is basically, let me give you the definition of a vector now. First, what is a vector? You have learned this one from your mathematics also. Now vector is a line that is described by the location of its two endpoints. This is what we mean by the vector itself. Like example, the vector, another example, like for example, let's say the rectangle, right? A rectangle could be, you can have 4 lines now. So this is also what we call them, is created with number of vectors. So when we say rectangle is a vector image because it comprises number of lines now. Now for example, most of the package helps you to design a rectangle, design a circle, design a ellipse. Most of the programming language compiler comes with lots of graphics library, and they come with all these tools. You can design a ellipse, and based on these, all these components, you can have a complicated graphics now. So by vector we mean simply a line which can have any number. We can have 2 endpoints, and then with these vector I can create a use a different type of command, rectangle, circle, and so on. Now and vector format file, when we say the vector file, the terms called, let me first define the vector, then let's see this one. Now we'll talk about the vector, what is a vector format file or vector file or vector image file. All the terms are similar to each other. When we say vector file or vector format file, consists of series of commands such as rectangle, ellipse, etc. There may be colors associated with the command also. So this is called the vector file now. Or basically what we are talking about is, here is you try to understand that when we say vector image, it contains many objects, right? Each object might be one rectangle, could be one object, another circle could be one object, or with combination of various smaller, these are primitive components are there. The rectangle, circle, they are primitive components. All the complicated drawings which you see now, you ask any architect which use a CAD package for designing any building and so on, the basic primitives are just few, and through this one you design any type of complicated graphic. Or take example of color, we have very few, 2 or 3 colors are there, and all the colors combination you see are basically shades of these 3 colors are, and so on. So basically there are only few primitives or few basic objects through which you can design a number of complicated graphics now. So when we say the vector image is basically consisting of number of smaller objects comprising of rectangle, circle, ellipse, and then you have a complicated graphics out of it. Now this is what we all explained to you, that vector images are built from basic primitives, line, rectangle, ellipse. These primitives may be grouped together to form objects. Now depends upon what I gave you, that my definition of object was a little bit much more higher side, but again it means that line, rectangle, if you combine them, then it becomes one object. But even frankly speaking, sometimes if the language does not give you to design a command for a rectangle, and you design a rectangle using lines, then even the rectangle has become object. But by object we mean something much more complicated, like for example, you have, otherwise you know the object from your C++. Now there we have also defined a object. Why we call them object? Because it represents the real life object. Now it could be a chair, or it could be a computer itself, could be one object. And another important characteristics of, just see this slide now once again, all the vector images are computer generated. You can generate through a number of different type of packages. So basically they are generated through computers, graphics, or computer based commands. Now, but let's try to see what is the drawbacks we have now with whole thing. Let me summarize very quickly. We are talking about the formats for representing the image now, and we gave you 2 different formats. One was what we discussed is vector, and second is what we are calling them bitmap. Today we are talking about but today most of the images are being are basically stored using a bitmap format. But let's try to understand why we are going towards the bitmap. What are the drawbacks with the vector image now? The drawbacks of the vector image is just here. The size of the vector graphics file, we call them the vector format file, is directly related to number of objects. It contains, and with many objects will not be only large but takes much time. The real drawback with this one, that if you have a complicated graphics, they contains more object, size is much more higher, then reconstructing this graphic will take lots of time. This is the one important drawback. It's very slow if you regenerate your graphics with these objects. The second is, it requires a software. Only through software you can generate those graphics. For example, the CAD package and lots of other the constructions tools are available there to produce image that is very time consuming. The another drawback is not that you cannot use them anywhere. You can use the vector drawings for the real world image production, but this requires a great deal of processing. That's lots of CPU time to process, and it's difficult to break this image down into simple objects. It's very difficult. What I'm talking about is it's very difficult to break this image, the object, into the smaller entities now. It takes lots of time to generate the graphic. If you have worked with earlier 386, earlier we have a 386 machines, the Intel 386 machine, and that time if you wanted to have a CAD package running on it, you must have a math coprocessor for it, only because the graphics package requires lots of processing time. So unless you add a math coprocessor just like a CPU, but is only meant for floating point representation, all the graphics, the mathematically they are represented into the floating point they require floating point operations for manipulations, and for that only you must have a separate chip, what we call the math coprocessors now. So it requires lots of time to do the processing. Then we have another image, what we call them bitmap image now. Now bitmaps are also known as raster graphics. Now assumes an image, what exactly mean by raster graphics now, the another format we are talking about. They assumes an image to consist of matrix of dots called pixels now. So when we say the raster graphics or the bitmap, is basically we are talking in terms of number of pixels and number of dots required to present the informations now. The size and the quantity of such an image or quantity, how big you want or how good you want, it all depends upon the pixel density and the number of colors it uses. The size of pixels, what we are talking about is that if size is very high, their size is dependent upon number of objects you have put into the vector here. Here size is dependent upon how many pixels do you want, how many different colors do you want, and so on. So all depends the density of the color. We'll talk about a little bit later on what exactly we mean by density of the color. So all depends upon the how big the picture is in terms of number of pixels and how many different color combinations you want to do. What exactly we are talking about is that if you have a black and white, you require only one bit, but if you use a different type of colors, if you have a, let's say, millions of colors you want to present to have a real life effect of the picture, then you require more informations, to more bits or more pixel to store those informations now. Now let's start is let me see this, come back to this one. For the monochrome image, if you have a black and white monitor, or if I want to present black and white picture, each pixel is either black or white. But for the color image, each pixel can be any color for a given range. The color depth of the image depends upon the amount of memory used to store each pixel. So basically same thing we discussed earlier, that if the monochrome monitor is there, or if I want to store black and white picture, I require a small bit, but if I want a good color combination, I require more bits to represent it. Now here is the density of the color now, and all the packages support this one, right? For example, the more common color depth are this following this one. If I use 16 colors, I use 4 bit I require to present this color. If I want to use a 256 color, I require 8 bit. if I use 32,000 onwards color, I want 16 bit, I require a 16 bit. If I require a millions of color, and you require 24 bits. So depends upon how realistic image you want to present. You have to use more higher density image side, and accordingly more bits are required, more pixel will be required. So this, the memory requirement must be very much understood. Accordingly, what for we are talking about is that if you want to produce a multimedia, if you are working on a multimedia project, then you have to estimate the size. Accordingly, you have to go for a such higher in computer and the software, because not all your earlier software didn't support all this color density. They were confined only to a small color density with 4-bit and 8-bit. But now we have a range. For that you must have a high powerful monitor. You must have a graphic cards attached with it. Right. So basically, let's try to understand in terms of the memory requirement. That is very much important to understand for you now. Like for example, if you see the bitmap images now. Now here is the what we have is that if you have a VGA card, if you have a VGA monitor, I'm not talking about Super VGA, now we are talking about Super VGA on higher side. If you are talking about this is the graphics card is attached with your monitor now, assuming that you have a colored monitor, then this is the pixel size, or what we call them resolutions of your monitor now. It's 640 by 480. What exactly means that so many, it is basically number of horizontal lines and divided by number of vertical lines or columnar lines and so on. So it means your whole screen is divided into so many dots or so many pixels and so on. For storing black and white image, I'm basically trying to explain you that if the color dimension is used, if color component is added to your graphics, how much image requirement gets increased. So if I have storing a black and white and you require 1 digit, so basically if right now I'm talking about bitmap image of one full screen. For that, if I have a 640 by 480 resolutions, it requires so many pixels, and for the storing 1 bit for one black and white, if you require 1 digit, this one. So to store a black and white bitmap image on your monitor, you require divided by, because 8 bits becomes 1 byte, you divide this one by 8, you require 37.5 kilobyte. This is what your requirement will be, right? But for storing the color image, the screen of your bitmap image becomes larger depending upon the color scheme. So it will be multiplied by 4 multiplied by 8. So your dot will be multiplied by 8 or 4 or 16 or 24, depends upon how much memory do you require. So again, your memory size will be much more higher, because each pixel not only represents informations about the image, but also it has to store the informations related to the color. So the size will increase drastically, but then only you can get the realistic picture, otherwise you will not able to get it. So real advantage of the bitmap is what we have. What the advantage we have? So stores very large amount of informations. A bitmap of, right, this is the real advantage, that it stores large amount of information, because informations are not stored in terms of a graphic object, but informations are stored in terms of bits. So we are talking about large informations can be stored with this one, right? A bitmap of sufficient resolutions, it can store every details of the scanned photograph. So right, so if you want to store very realistic or a scanned image, you have better you go for the bitmap type of presentations, bitmap of format. What is the basically disadvantage then? The disadvantage of just here, disadvantage will be, again here also will be, there is the processing time is much more higher, right? Because if you increase the size, if you have more vector, the size will be higher. I'm talking about the vector now. Then it will be time consuming. Here the again memory will be required depending upon requirement. Just see, look at this slide and then we'll come back to explanations. The large amount of space needed. The amount of space depends upon the resolutions, not depends upon the object, that is number of horizontal and vertical pixels and its color depth. or color density. For example, 640 by 480. This calculation I have given you roughly 640 multiplied by bitmap graphic or VGA screen with 256 color will be how much? It will be 8 multiplied by 846 and so on. So many bits are required, roughly 300k storage image you require to store the bitmap image. But the regeneration of this bitmap graphic, if you want to regenerate or reconstruct this one compared to the vector format, it is much more faster than this one. Now here is then how we create a bitmap image. That is one thing. Various ways I can create a bitmapped image now. One way that I have a various packages. Now various ways I can do it now. One is the paint and drawing package usually store image as bitmap. So I basically through software packages I can store then bitmap graphics, right? I can do some scanning of the image. I can scan the image and also I can store them. So all your scanned image, you have a digitizer. Through digitizer you have any color photograph, you digitize them. Through a scanner you can scan them and finally store into the computer's memory. Then that also you can store them. So all these scanned images from the scanner, it basically stores them into the bitmap image, not in the vector graphics now. Generated by capturing a computer capturing a computer screen snapshot. Suppose that I have a certain image on the, I have downloaded certain picture from outside on my monitor now, and then again I can take a snapshot and store them in your hard disk or the floppy. Then again that is way that one also uses the same format as what we had what we had with a scan image. So what we are talking about is that we have discussed the three important ways to create the bitmap graphic. One through the drawing packages. The second might be the Corel Draw, might be one of the packages now to create this one, or any of the Adobe Photoshop, right? They also, all these graphics basically packages store the image into this format. Then we have a scanned images, and then again I am taking the snapshot of the pictures which I have downloaded from anywhere around the world and storing them into the hard disk. That also is basically this one. If I take the memory size, if I try to do benchmarking of both the formats on the memory size, then what I find that the vector image takes less memory. If you see this one, vector image takes less memory, but the bitmaps takes more. This is here, so it takes more memory compared, because right. But what I am talking about is that if I have to regenerate the whole this one, if I have to regenerate the whole graphics role image now, then bitmap image is much more faster than the vector this one, because I can break them into number of smaller pixels in the bitmap for if the graphics is represented in the bitmap form, but it's very difficult to break them the vector image into a smaller objects. I can't go beyond that. That is why it's very difficult to do it. Using a single bitmaps for complicated image may give you the faster screen refresh performance. Means is faster. I am talking about regenerations in form. If I have to regenerate, it gives you faster refresh performance than using a large number of objects in vector image to make that same screen. Here is the basically I am doing some benchmarking. One way to compare is the memory requirement. There you found that bitmap image takes more memory. The another benchmarking for both the images formats is that the faster, I mean the computing time, because you require a computing time to represent this whole thing. Then we found that bitmap is much more faster to generate, and that is the reason that people now today all the informations are represented as a raster graphics, or what we'll call them bitmaps images now. So everything you download, everything today we have in the bitmap format. Let's continue further. Now where does light come from? Let's try to understand some basic fundamentals of this one. The concept of a light or the color came from two physicists. One was Max Planck and the second was what called Niels Bohr. The you must have remembered the theory of quantum theory in physics. So basically, if you want to understand where does light come from, you have to little bit understand what is the quantum theory, which was developed by Max Planck. And later on, the Niels Bohr elaborated this concept with different type of experiments. Let's talk about what the Max Planck had to say about it. Now here is again answering to this question which I raised earlier today, that where does light come from, what exactly the quantum theories or Max Planck says related to this concept. According to the Max Planck, light comes from an atom. You know that what is atom? When an electron passes from a higher to a lower energy level. So when the atom passes from the higher to the lower energy, it throws some light, and that is basically we are talking about. Let's try to understand this concept a little bit in detail. Is what Niels Bohr did now. He experimented and showed that an excited atom that has absorbed energy and whose electrons have moved into higher orbits will throw off that energy in form of quanta or photons. Please read as a photons, where it reverts to stable state. So basically two theories are there. One is by Niels Bohr, second is by Max Planck. So this one you can derive what is the light now. Now the color is then now what we are talking about, then what is the color? What is the combination between light and the color? The color is a frequency of a light wave within the narrow band of the electromagnetic spectrum to which the human eye responds. So, right, it's basically we are talking about certain frequency range of the color, right, which a human eye is able to respond to it. That is what we call them and in computer network we have talked about spectrum of basically the radios. We talk about the spectrum in terms of the radio frequency. You know that basically we discussed that there, if you remember, if you try to relate, basically I am not explaining, don't get confused with these two concepts. I am talking about the concept of a frequency. I am trying to explain you. Basically there we discuss the concept of the wireless network or the mobile network, right? One way we have a wired media, another we have a wireless media. In wireless media, the information, for example, you are moving around and can download a email or database from anywhere in the internet through your mobile computer. So their information is being sent through the wireless media, right? Use the radio signal for downloading the information. So they all have certain frequency range for using all these things. Like when you talk to somebody on the cellular phone, again they use certain frequency range and so on. So the color is also a frequency of light which a human eye can absorb. If you are not able to absorb certain things, certain color which are such a frequency range which human eye cannot observe them, you can't see them, and we'll talk about all these things here. So you have to go into details of theory as well as what a software, what a package is providing to do it. Now here is, let's say, the colors of the rainbow. Please see this slide now. The colors of the rainbow was basically what it comprises. A rainbow which you see, red, orange, yellow, red, orange. It is orange, please read as orange. The yellow, green, blue, indigo and violet. This is the color, this is the range which comprises in the rainbow. Are the frequency range is basically in ascending order, in the ascending frequency of this visible light spectrum now. So we are talking about the colors is basically one of the frequency range of the light or of the light spectrum now. Right, so red has a higher frequency, that is why you see them much more darker, and then orange little bit lesser than, yellow is again little bit lesser than, and so on. Now let's talk about some of the different let's talk about some of the characteristics of the natural light and the color now. And here we'll talk about the infrared light. Now here is what with the infrared light. Let's see this one here is the infrared. Let's talk about some of the characteristics of this one. Of course you are not using this light, but since it's a part of the whole color topic, let's try to discuss little bit on this topic. What is the infrared light? These are the few characteristics of infrared. Below the frequency of the red light, not perceived by human being, you can't perceive them. right, can be created and viewed by electronic diodes and sensors. So these are the various devices through which you can create the infrared light, but it's not perceived by the human being, it's not basically used. They can be used for the communication side, but normal when we create a multimedia type of package, we don't use this type of color or this type of a light at all. Light and both are same thing, but we are talking about only the difference is that which one has got a lower frequency, which one has got higher frequency in the light spectrum. Then we have ultraviolet light. This is another characteristic now, beyond the higher end of the visible spectrum and can be damaging to the human. Again, this is a human eye cannot absorb this type of ultraviolet light, because this is basically the spectrum which a human eye can respond to it is much more higher than that. That is why we are not able to do all these things now. And then you can find out the spectrum now in the light spectrum about the colors which use red, green and so on. Right. So then we have then what is a white color? What is a basically noisy mixture of all the color frequency in the visible spectrum, the produced by sunlight and the fluorescence tubes. This is all we have. If you have any queries, please give me email, or you can raise the question next time. I will be happy to answer your questions. Thank you very much. With this I am able to conclude.